Alright, welcome to Chapter 10. This is going to be all about radical functions and a little bit of geometry at the end, but mostly focusing on radical functions, the square root function, graphing it, solving equations, and simplifying expressions that have radicals in them. So this first video, I call it 10.0. It's not actually one of the sections in the book. It's just a reminder to get your idea around what is an inverse function, because we're going to relate the square root function, or radical function, back to parabolas and quadratics that we just learned about in the previous chapter. So a couple of vocab words. First is inverse function. This is something we learned about a long time ago, I think way back when we were learning about straight lines. To get an inverse function, you swap the input and output for whatever the mapping was. So if you recall, we had x and y, and we said certain x values would map onto certain y values. This was when we were learning what a function is. So to get the inverse function, you exchange the input and the output. So you swap the y-coordinate with the x-coordinate. So for individual coordinate points, you just switch the x and y coordinate, and for an entire function, you could exchange the x and y variable and then resolve it. That was how you found the inverse function. So just keep that in the back of your mind. The notation, just to refresh memory on that as well, the notation for an inverse is a little -1 right here. This is not a power. It's important for you to recognize this is not f to the -1 power. It's pronounced f inverse, or the inverse of f. So either f inverse of x or the inverse of f. And this right here is your notation for an inverse function. Again, not an exponent, just inverse. Alright, let's apply that idea to this example. We've done inverses of linear functions before, but we've never done an inverse for a quadratic. So here's our function. Let's replace f of x with y just for simplicity. So we can write y equals x squared. So the first step to finding the inverse was to swap the x and y, or the input and the output. So we can write x, change y into x, and change x into y. So I replace y with x, I replace x with y, and now I solve like normal. So if I want to solve for y, I need to take the square root of both sides. And when I take the square root of both sides, I have to add a plus or minus. That's the same as if we had done the branching, the +1 and the -1. So what I get is y equals plus or minus the square root of x. And then we can change y into f inverse of x equals plus or minus the square root of x. So here's our inverse function. Of course, I did already have the answer written right here nicely, but I hope you see the process that leads you there. Now, what is this graph going to look like? Well, to graph it, we have to think about our old graph. Let me do the old graph in a different color here. An old graph was a parabola. It had the point 0, 0, over 1, up 1, over 2, up 4, over 3, up, say 9, and then backward 1 here, here, and here, right? So let's just take those coordinate points. And if I switch back now to red, if we exchange the input and the output, this is 1, 1. If you swap them, you still get the same point. Well, this one is 0, 0. If you swap them, you still get the same point. This one, though, is 2, 4. This was over 2, up 4. So if you swap those, instead you're going to go over 4, up 2. This one here was 3, 9. If you swap those, you're going to go over 9, and then up 3. So here, you can see that we're building this in. And then the negative side, -1 up 1 is going to become down 1 over 1. -2 up 4 is going to become over 4 down 2. And -3, 9 is going to become over 9 down 3. So when we exchange all of these points, we end up with 2 halves. And now you can see positive square root of x is this part up here, and negative square root of x is this part down here. So one more thing to mention here is we have the vertical line test. So remember, if we draw a vertical line, this crosses, it's not very vertical, but you get the idea. This crosses twice, once here and once here. So this function actually is 2 functions that are both drawn on top of each other. The top half is one function, and the bottom half is a separate function. So by putting plus or minus here, we're actually saying it's 2 different functions. One of them is positive root x, the other is minus root x. You can't do it collectively as one function because it doesn't pass the vertical line test. Okay, that's it for this video. I hope that gave you a quick reminder about inverse functions and a specific example related to the square and square root. We're going to dive a lot more into this function here, the square root of x, coming up next.